You need to have printed out the Chapter 9 notes because there's a lot of definitions, and you'll also want a highlighter. So if you don't have that handy, pause it right now. Now in Chapter 8, we took a sample and made some kind of estimate about a population parameter. So we had the formula x bar plus or minus z sigma over square root of n, and that gave us a confidence interval. Well, hypothesis testing is related in a way, but what we're going to do is we're going to assume something about the population, maybe based on history or studies, and then we're going to use a sample to test it. Now, like I said, there's a lot of definitions, a lot to read. Let's go through and highlight the important things, and I'm going to also write some notes to clarify some of these. Now, a hypothesis is always going to be written as a statement about a population parameter, for example, mu. So it'll always have mu or pi in there. Pi is a population proportion. We're going to have to write two hypotheses. The null hypothesis H of O will always contain an equal sign. It could be equal, less than or equal, or greater than or equal. And we're going to decide if we're going to reject it or not. Now, another way I can say this is our current belief, because sometimes students aren't sure which ones are null hypothesis and which one's the alternative. So that's what we currently believe based on what we've seen. The alternative will never, and we'll use H of 1 there, will never contain an equal sign. And these will always be mutually exclusive. Only one of them can be true. Okay, here's an example. Let's write, because we're going to have to write hypotheses. We're the manager of a fast food restaurant, and based on the past month, we've had a waiting time of an average of 4.5 minutes. State the null and alternative. What we believe, what we've seen is that the average time is 4.5. This is how you write a hypothesis. You've got your colon here. This is always a population. Always has one of these signs here. The alternative is what we're trying to prove. We're trying to decide if it's changed. So another way to look at alternative is what we're trying to prove. Has it changed? Is it not 4.5? Okay, we'll be seeing a formula for test statistic. The next thing we're going to look at are critical values on this next page, and that's going to divide our area into regions of non-rejection or rejection, okay? And this test statistic, if it falls in the region of non-rejection, we do not reject the null hypothesis. If it falls in the rejection, we do. So let's look at this next, regions of rejection and non-rejection and critical values. We're going to have to decide on a significance level. This is alpha. And we're going to be looking at two-tailed tests in this section. So these are always two-tailed tests. So if alpha is 0.05, this middle part is 0.95. And this is our non-rejection region. That means these two tails, if we fall here or here, we will reject the null hypothesis. Now remember, these areas are going to be alpha over 2. So 0.05 over 2 is going to be 0.025. And if you go to your z chart, or you might remember for this particular value, our z was positive or negative 1.96. if we don't know that, we go to the body of our chart, and these values are always the same. They're the same distance from the middle. Go to 0.0250, and you find that here, and that's negative 1.96. Now, I will clarify here, in this homework, you need to make yourself a note. For alpha equal to 0.10, which was our 90% confidence level, we were using positive or negative 1.65. They are going to be using positive or negative 1.645 in this homework in 9.1 for that alpha level, because if you look here, negative 1.65 and negative 1.64, you'd really have to go right between those to get that exact 0.0500. So just make yourself a note here for the homework. Okay, now we got a test statistic, and we'll look at this formula later of this. Well, this falls between these numbers, so it's in the non-rejection region, so we will not reject H of O. Another example, we have this level of significance for alpha. Again, all these examples for the first section will be two-tail, and we'll make a decision about that, but we need to get our critical numbers. So we need to find z at alpha over 2. If you take 0.075 and divide it by 2, you get 0.0375, which is not one of our standard numbers, so we will have to look that up. 0.0375, and we're going to find that here, and that's negative 1.78. Remember, this middle is going to be our non-rejection region, but we will reject if we're out here or here. Well, where is 1.83? It's going to be to the right here. It's going to be in the rejection region. So we will reject our null hypothesis. Now, of course, doing this, we're gonna make some incorrect conclusions. There's two types of errors, and you can only have one occur. You can't have two. And I'm gonna highlight the wording that you should look for in the homework. Let's highlight this sentence. A type 1 error occurs if you reject the null when it was true and should not have been rejected. Okay, so maybe we're just overcautious. And a type 2 occurs when we don't reject it and it's false and it should have been rejected. And again, these cannot occur at the same time. And we can adjust these errors occurring by adjusting our numbers for alpha. So we say alpha is our level of significance, and the probability of a type 2 we call B or beta. Okay, but let's just go ahead and clear that up with some examples on the next page. So let's look at this scenario here. We have a snack food company, and it has a certain size bag of pretzels. So let's go ahead and read through this here. And you can see they make some claims. That's what they believe to be true. And we're trying to decide if that's not true. Well, here's a chance to write our null alternative again if you want to pause it and try to write it yourself. We're assuming that we are getting that mean weight. The alternative is that we're not. Now, what would be an example of a type 1 and type 2 error? Okay, so type 1 would occur if we rejected this and it was actually true. This is what we call a false alarm. And we might shut things down necessarily. We might say, oh, wait, something's going wrong with the manufacturing process, when really everything's good. A type 2 error would be a missed opportunity to find that the mean is not 454, and we should have made a correction there. And of course, a correct decision would be that we didn't make an error. Okay, so let's look here. Suppose the results of carrying out the hypothesis test lead to the rejection of the null hypothesis. Let's see if we can classify that conclusion by error type or as a correct decision if, let's say, the mean weight is actually 454. And again, we reject. Remember, if HO is actually true, that is a type 1. If HO is true, that is a type 1. It was rejected and it should not have been. Okay. Now, if HO is false, that is your type 2. So here we find that HO is false, and so a type 2 error would fail to reject H of O. So we didn't have that occur, so in this case, we had neither error, and so we had a correct decision. So a type 1 error can only occur if HO is true, which it's not here. A type 2 error would lead to failing to reject, which it didn't happen, so we're good here. Okay, in County A legal system, a person is considered innocent until proven guilty. Okay, so that's our assumption here. That the person's innocent, alternatively they're guilty. They have two potential decisions. They can decide to convict, which is reject HO, or not convict, which is do not reject. What type of errors are we talking about? So a type 1 error that would be that the jury convicts an innocent person. Okay, they rejected what was actually true. Okay, they rejected the fact that the person was innocent, and that was actually true. A type 2 error would be that the jury says a person is not guilty when they really are. So that would be we fail to reject H of O, and that would be the type 2 error. Now, here is going to be our how we calculate the test value. The other examples we were given for the rejection, non-rejection, they were given to us, but they come from here. You probably recognize that formula. We have to assume it's normally distributed and that the sample size is large enough. And we've got this process here. Okay, so this is a lot to take in here. So what we're going to do is we're going to continue to work through this process. In the next video, we'll refer back to this, but we have done some things already. We have stated the hypotheses. We have looked at a level of significance alpha, and that will be given to us. And of course, that might determine whether we make type 1 or type 2 errors. And the appropriate test statistic will depend on whether we need to use Z or T. We talked about critical values. And then we're going to do some examples where we actually make a decision. So we'll stop there, and then we'll continue on in the next video.